Hello guys, now the topic will be rotations. Rotations are present in AVL trees. The full form of AVL is Anderson, Welsky and Landis. So here those are the scientist names. So coming to the rotations, we have totally 4 rotations. Those are RR, LL, RL, LR. Here R represents right, L represents left, which means right rotation, left rotation, right rotation and left right rotation. If we got RR or LL rotations, then in that we need to keep middle node as a root node. If you got these rotations RL and LR, then we need to keep last node as root node. We will be very clear with an example, so that's why we need to take an example here. Here we have the elements 10, 15, 20. 15 is greater than 10, that's why it need to keep right, and 20 is greater than 10 and 15, that's why it should keep on right of these numbers. So left is empty, here also left is empty. So our rotation here 10 is right, 15 is right to the 10, 20 is right to the 15. This is an RR rotation, that's why here middle node should be the root node. It will become 15 as a root node, 10 is smaller than 15, 20 is greater than 15. This is the RR rotation example. I hope you'll be clear with RR. So here I have an example for LL. So here 5 is smaller than 10 and 2 is smaller than 5. That's why it is placed on left of these numbers, and this is left to this and this one is left to this node. So this is an LL rotation. For this we need to keep middle node as root node. Here middle node is 5 and 5 as a root node. 2 is smaller than 5 and 10 is larger than 5. So the final LL rotation correction tree is this one. So coming to the next rotation. This is RL rotation example. Here we have right and left rotations. So last node should become root node. Here 15 become root node and this will be 10, 20. This is a balanced AVL. And coming to the LR rotation, here 5 is smaller than 10 and 7 is larger than 5. That's why it is LR. And the final balanced one is here. So coming to the very important aspect in rotations, when do we use rotations? We have the formula for balancing factor. The balancing factor formula is height of the left subtree minus height of the right subtree shouldn't over 0, 1 or minus 1. While constructing an AVL tree, this balancing factor is very important. Let's take an example to see these rotations. Here we have 30 and these elements. Here we have for 70 we do not have a right or left subtree, that's why it is 0 minus 0, 0. Height of the left subtree minus height of the right subtree is equal to 0. Height of the left subtree 0, height of the right subtree is 1. So that's why 0 minus 1 minus 1. Okay, minus 1 is okay, 0 is okay. And height of the left subtree is 0. Height of the right subtree is 1, 2. 2. 0 minus 2 minus 2. Minus 2 is not okay. So that's why it is R rotation. Here we need to use RR rotation logic. So this is the process for all the rotations in AVL tree rotations. So this is the topic of rotations. Thank you so much. If you understand the topic and if you like the content and if you want more videos from me, then please do subscribe and comment below.